Okay, we're going to bring in a solid model, X_T format, which is the parasolid for the start of our program, and I'm going to rotate this, select the face that I want to be perpendicular to the z-axis. Maybe I want to rotate this now, that's the way I want to hold it in my device. So if I say show me the face view, that's now the face that I'm working on. Continue on. The top of the part is going to be my Z absolute 0, and you can see we've got he's drawn this part on center, so I don't have to center it up. But if I wanted, say, the corner to be my 0, I would select the intersection of two lines, say this line and that line, and that corner is now my 0. So you can put 0 wherever you want it. You also have the ability to offset your absolute 0. So you could, if you had no way of putting it on center, you could make it go on center just by, if I inquire geometry. That's 10 3/4 inches long, and it's 8 3/4 inches in Y. So I could just go back and then offset that half of that distance in X and Y, which would put me back on center. You also might want to use inquire geometry to pick your smallest radii, so you know which size tool. And these are all 200s. Those are all 200s. These are pockets. These 4 are pockets. These 4 are standing up. So I know my smallest radius is 200. So I'm going to pick an island because I want to do these stand-up islands first. So I'll pick island, and it says you want to chain the boundary. Yes, I do. I'll just pick 2 entities counterclockwise so that I climb cut that pocket. And then I'm going to pick my islands in a clockwise direction, which will climb cut the islands. You can pick them in any order you want, but the order you pick them in is the order the cutter is going to be driven. Now I'm going to come into event. My default Z rapid is 30 thousandths because I've told it to do that. For my ending, I don't know how deep this is, so I'm going to go to the solid view and just pick on here. This is how deep it is. I can see that's 1/4 inch. And I'm going to tell it I don't want any offset. And it pops the number straight in there for me. I can go number of passes, or you can set it up number of passes or depth per pass. I'm set up for number of passes, just do a single pass. I've put a default finish cut in there of 20 thousandths that I like to use. I'm going to run this at 5,000 RPM to rough and finish. I'm going to helix in at 40, clear it out at 80, finish it at 60. I'm going to use tools 1 to rough and 2 to finish, and I can go 1/8 of an inch per pass with my finish tool. You can make that whatever you want. You can come in now if you want to come into your tool table. I could tell it that a 3/4 inch finisher is my tool 1, and that was a 200, so I'll use the 3/8 for tool 2. You go into program mode. Okay, let's just look at the part. Looks pretty good. Move on. We can just go into program mode again, back into our solids, and we'll do these pockets. So we say pocket, chain, yes, and I'm going to pick these in a counterclockwise manner. Excuse me. That's my default. I these are through holes, so I'm going to come over here and click on the back side of my part. I can see that's a 1/2 inch thick plate, and in my defaults I've got set up already that for if I'm going to mill through, I want it to add an additional 30 thousandths to whatever the thickness is. You can do that too with a drill, so it'll take your drill tip, your thickness, and 30 thousandths, put those numbers together if you're drilling through. And your default's E-rapid for the parasolid offsets. You're going to do that one time and leave it alone. So it's a 1/2 inch thick. I'm going to say with the offset, I made it down to 530. Single pass, finish cut. And I'll use tool number 3 and 4 for the pockets. And let's do this pocket. Now I already know it's 530 is my number, so I don't have to go pick it again off the solid. Notice you remembered the tools, but it'll let you change the feeds and speeds because this pocket may be different than the last pocket. Use pocket. I'll just shut up and finish this now. And I'm done. I'll make this a 1/2 inch. Number 3 and number 4. I'll make this. Okay, let's go in now to our verify. And it's going to take a while for this toolpath to process. The reason being the strategy that I picked for this is adaptive machining, which is circular cutting, using 30% of the 35% of the end mill per pass. I'm cutting it one way, which means I'm always in climb cut mode. And this is what allows me to program the feeds and speeds that you saw. I mean, we were doing a helix into the part at 40 inches a minute. We were roughing at 80 inches a minute and finishing at 60. But the roughing of the part at 80 inches a minute, my God, you can take a 1/2 inch end mill, a 1/2 inch deep in aluminum, and run that thing about 120 inches a minute feed to rough, and put no strain on the cutter and no heat into the part. In fact, the harder the material is, the better this is, because this strategy is because the heat comes out with the chip and does not go into the part and work hard in the material. So the adaptive strategy takes a little longer to calculate, but it's going to machine your parts probably 4 to 5 times faster than what you're able to do it using conventional machining strategies. All of the major CAD/CAM packages now offer this strategy. Some of them offer it as an option, but I tell you what, it's it's a game changer. It's what it is. So let's look at this part now, and we'll do a verification of it. Here it's roughing out the islands, and you can speed up and slow down if you want. You can go down into single step and go block by block, and zoom in, zoom out, rotate it, look at it however which way you want to. I'm going to speed this up if you want. You can actually go up to 20 times the speed And that would be for larger G-code files that you might want to run on this machine. We handle G-codes as well as we do the conversational. A lot of people don't know that, but we're actually quite good at it. And these machines are super efficient in how they process the data and execute it. So now it's going into the rest milling in the corners to clean them up, and now make a finished pass. That looked pretty good. And now we're doing our through hole pockets and doing the rest milling on those as well. You don't have to go through it like this if you want. You can just show the part and it'll show you what your finished part looks like, if that's what you're interested in. I'm mainly looking to make sure that I don't have different colors bleeding into different colors, or you know, a cutter running through an island or something like that. Because what you're seeing here is a verification of the G-code that we create, transparent to you, of course, but we do generate the G-code, and this is the result. What you're looking at here is the G-code that's going to run the machine. So if it's correct here on the screen or at your control, then it's going to be correct when you cut the part. You can rest assured. So thank you for watching.